So in this video, we'll be going over the second part of the Fundamental Theorem of Calculus. There's a separate video for the first part. If you just want to go through worked out examples, skip to that part of the video. For now, I'm just going to explain and go through what the second part of the Fundamental Theorem of Calculus is. It's going to be one of the more important consequences of taking this course, either Calculus 1 or AP Calculus. So just for anybody going into higher level mathematics or even like engineering and physics, anytime there is a fundamental theorem of this, it's going to be one of the most important things in the course. Fundamental theorem of calculus, fundamental theorem of graph theory, fundamental theorem of algebra, all of those super important to the entire field of calculus, graph theory, whatever it is, right? So part 2 of the fundamental theorem of calculus will help you take definite integrals, right? Integrals over a specific, interval. So it says here, if I have the integral of a to b of some function f of x, the way I can compute that is this capital F of x is the antiderivative or indefinite integral of your original function. And if I evaluate that at b and subtract it by that the capital F of x evaluated at a, I'm going to get this final answer. Okay. Now, let's work through some examples of this. So we'll start off simple with this. Just the integral from 2 to 6 of 5x minus 7. All right. So the first thing we're going to need to do is find the indefinite integral of 5x. Okay. So this is something you should already know how to do. And that's going to end up being 5x to the second multiplied by 1/2, which I'll just write as 5x to the second over 2, subtracted by 7x. Integral of 7 is 7x. And that I'd write here as I still need to do that computation that we talked about here from my lower bound to my upper bound. Okay, inputting in 6 will get me 5 times 6 to the second over 2 minus 7 times 6, and then minus, I have to do the 2 as well, 5 times 2 to the second over 2 minus 7 times 2. And at this point, just do this computation. If you're allowed a calculator, you can do it in a calculator. It's pretty simple to do it by hand. You're going to end up with 52, as your answer. Right? Pretty straightforward. All we did is find the indefinite integral of 5x minus 7. Set x equal to 6 to find this half of it. Set x equal to 2 to find this half of it. Then subtracted the 2. Now let's move on to the next one, right? So as you know, the first step, find the indefinite integral of this. 6x to the second minus 5x plus 2. So calculating the integral, we end up with integral of 6x to the second is going to be 2x to the third. Negative 5x gets us negative 5 over 2 x to the second. And then the positive 2 just gets us a positive 2x. And our lower bound is negative 3, while our upper bound is 1. Now all we do is input in these values. 1 to the negative third just gets us 1, and 1 times 2 is just 2. 1 here, 1 to the second is just 1 times negative 5 over 2 minus 5 over 2. And 1 times 2 is just 2. Now let's calculate it for negative 3. Right? And that's just a pretty simple computation to do. You're just substituting in negative 3 for all of these values and seeing what you get. We get negative 54 here. We get negative 45 over 2 here. And we get a negative 6 here. Now simplifying this all, either putting it into your calculator or doing it by hand, we're going to end up with 84 as our final answer. For our next question, we have the integral of 1 to 4 of square root of 6 over x dx. Now, before I actually do the computation part of it for figuring out the definite integral, when I integrate this, I want to change it into a form that's easier to work with, you know? So first we need to find the indefinite integral of 6 over x. So I'm going to change this to an exponent that I'm familiar with, and then distribute. Now, a rule you should be used to using at this point is you're able to kind of take out constants from integrals and move them to the front. So this 6 to the 1/2, or rad 6x, rad 6, is going to be put on the outside. And all I'm going to do is integrate the 1 over x to the 1/2. Now, x to the 1 over x to the 1/2 is the same thing as x to the negative 1/2. Integrating that gets me a 2 times x to the 1/2. And then I just have essentially 2 times x to the 1/2, which is just square root x. Multiplying all this together leaves me with 2 times square root of 6x, right? And that's the indefinite integral that I'm going to use. So now, taking this, this now becomes 2 rad 6x to the, and then the bounds are 1 and 4. And now I substitute. 2 rad 6 times 4 gets me 24. Subtracted by 1 times 6, so that's 2 rad 6. And now I just simplify from here. I can combine it to become a single term. The rad 24 can split up into a rad 4 and a rad 6. This can't be simplified any further. Now, a square root of 4 is 2. 2 times 2 ends up being 4. I'm just going to write that up here. 4 rad 6 minus 2 rad 6 leaves me with 2 rad 6 as my final answer. Now for the last example, I'm going to do an example using trig functions. Right? Integrating those should also be fairly straightforward at this point. Okay, so just getting right into it, taking the integral of this. Our question is the integral of 0 to pi over 3 of 2 times sine theta minus 5 cosine theta. So let's integrate them one piece at a time. So the integral of 2 sine theta is just going to end up being negative 2 cosine theta. And the integral of 5 cosine theta is just going to be 5 sine theta. And we have to put our bounds on that. Next, we go in and just substitute. So -2 times cosine of pi over 3. Now, this should be kind of memorized from the unit circle. You should still remember what at least that first quadrant all equals, because that's the only way you'll get an exact answer for this. If you try to use a calculator, you're going to get some decimal that you might need to round. So the value of cosine of pi over 3 is going to end up being 1/2. So we end up with -2 times 1/2 minus the value of sine of pi over 3 is rad 3 over 2. So that's going to be 5 times rad 3 over 2. And now minus, we're going to substitute in 0. Cosine of 0 is just going to end up being 1. So it's going to be -2 times 1 minus 5 times the sine of 0 is just 0. So 5 times 0. Simplifying all this down, we end up with -1 minus 5 root 3 over 2 plus 2. Simplifying this one step further, our final answer is 1 minus 5 rad 3 over 2. Okay. So being able to take a definite integral, super important to really any math course, physics, engineering course you take after this. Really important skill to have. If there are any questions, you can throw it down in the comments. Other than that, good luck, guys.